Hello, this is the video for Chapter 5, Lesson 3. Today we are going to continue with this idea of solving inequalities, but we are going to add an extra step. So today's lesson is basically going over solving multi-step inequalities. So like we said before, an inequality is really just a problem where instead of an equal sign, it's a greater than, less than, greater than or equal to, or less than or equal to sign. And the one thing to keep track of is if we are dividing or multiplying both sides by a negative, we have to flip the inequality. So everything else that we're going to do is exactly the same as just solving an equation. Let's take a look at A. If we're solving this inequality, the first thing we have to do is, well, first of all, if we look at this as a regular equation, the first thing we have to do is add 7 on both sides. So we're going to continue with that rule of algebra and isolate the variable. So 17 plus 7 is 24. Then I'm left with negative 6a is less than or equal to 24. The next step would be to divide by negative 6. And already we're seeing our first problem where we're dividing by a negative. So the key here is that we need to flip this inequality. So rather than it being less than or equal to, it's now going to be greater than or equal to. Our negative 6's cancel, a is brought down, and 24 divided by negative 6 is negative 4. When in doubt, check your answer. Plug this back in and see if you have a true number sentence. If I plug negative 4 in place of a, negative 6 times negative 4 is positive 24. Positive 24 minus 7 is actually exactly 17. You can put a value that is greater than negative 4 and check. So a value greater than negative 4 maybe would be like 1. So negative 6 times 1 would be negative 6. And negative 6 minus 7 would be negative 13. And that is, in fact, less than or equal to 17. So that is a true number sentence. B, same steps here. I'm going to add 30 to both sides. I'm left with 80 over here is greater than 0.8x. This cancels. I'm going to divide by 0.8 in order to get x by itself. Let's back up for a second. I made a mistake. Did you notice what I did? I added 30. Why did I add 30? We should subtract 30 on both sides. We're left with 20 is greater than 0.8x. Divided by 0.8. 20 divided by 0.8 is 25. I don't have to do anything different because I'm not dividing by a negative. So 25 is greater than x. You can also write this as x is less than 25. If we were to plot this on a number line, 25 would be here. It would be an open circle shaded to the left. All values to the left of 25 can be a potential answer for x. Let's quickly graph this on a number line. Negative 4, are we going to bubble in or keep it open? We're going to bubble in and shade to the right because we have to find a value that's greater than negative 4 for A. Problem 2, the word problem here. You want to make a rectangle banner that is 18 feet long. You have more than 48 feet of trim for the banner. What are the possible widths of that banner? So let's draw a picture. You want to create a rectangular banner, and you have trim, meaning it's the edging. Okay, so this is kind of talking about perimeter. This word trim is kind of indicating to you that it's talking about the perimeter. So whatever the perimeter is, I'm going to put P here, it cannot be greater than 48. It could be equal to 48. So I'm going to use this less than or equal sign to talk about how that perimeter or the trim has to be. And for a rectangular shape, it says it's 18 feet long, which means long ways, it has to be 18 feet, okay? So we've got options for the width, right? We could do 48 minus the length, which the total length would be 36, and then divide everything by 2. Or you could think of alternative ways to kind of piece this trim together and have a different length, okay? So could you use less than 48 feet of trim to create this banner? You could, because you don't have to use all of the material. So you could, you could use the maximum amount, or you could use less than 48 and still find a different width that works for what you want to make. So let's write out our equation based off of the image that we're seeing. We know the width. I'm going to use a variable to kind of demonstrate the width. It's going to be x. So if I were to create an equation, I might say something like 2x plus 2 times 18 has to be less than or equal to 48. Okay, so then I'm going to simplify. 2 times 18 is 36. So I'm going to bring that down and then subtract 36 on both sides. Now I'm left with 2x is less than or equal to 12. Divide by 2 on both sides. X has to be less than or equal to 6. If you want to use up the full 48 feet, you could make the width 6 feet, or you can use less than 6 feet for your width and use less of the trim available. Okay, problem 3. What if we see the distributive property? Like we've said before, it's just like you're solving a normal equation unless you have multiplying or dividing by a negative. And so we're going to work this out like a regular equation, but instead of writing a equal sign, we're just going to write the inequality that's given to us. 2 is distributed into 4m. 2 times 4m is 8m. 2 times positive 7 is positive 14. I'm going to write this positive as my operation. But again, I'm doing a silly mistake that I have warned you guys not to do. And here I am making this silly mistake. What did I do? I forgot to circle my term as a -2. And when I distribute it, it should be a -14. So if you caught this before I even changed my answer, then good for you. If not, then here we go. A mistake that's easily made. I'm going to highlight my like terms, -14 and 8, and sorry, -14 and 5. -14 plus 5 is -9. I'm going to bring my -8m down. Do the opposite. Add 9 on both sides. 15 plus 9 is 24. 24 is less than or equal to -8m. Okay, this cancels. I'm left with -8m. We see a situation where I'm dividing by a negative. So what do? Flip the inequality. -8 cancels. I'm left with m. 24 divided by -8 is -3. The answer is -3 is greater than m. If I wanted to flip this around, I could write it as m is less than or equal to -3. If I were to graph this, it would be a closed bubble, and I'd shade to the left. What are the solutions of 3b plus 12 is greater than 27 minus 2b? So what do we do when we have a variable on both sides? It's going to be the same exact steps, I have to combine my like terms. So I'm going to add 2b on both sides, leaving me with 5b plus 12 is greater than 27. Subtract 12 on both sides. I'm left with 5b is greater than 15. Divide by 5 on both sides. I don't have to flip my inequality because the 5 is a positive. Divide by 15 divided by 5 is 3. B is greater than 3. What happens when we have some special situations? So let's take a look at what happens here. These are special solutions. If I were to combine my like terms with my variables, let me subtract 5n on both sides. Quickly, I realize if I subtract 5n on both sides, I have a weird number sentence. It says 9 is less than or equal to -1. Now, this is not a true statement because we all know that 9 is not the same thing as -1, nor is it less than -1. So this is a false statement. When we see false statements, oftentimes is when the variables cancel or you're left with n equals n or something like that. What we see is a no solution. Remember, we call these problems no solution because there's literally not any value you could put in place of your variable and have a number sentence that's true. Looking at B, if I were to first combine my like terms here, 7x minus x would be 6x plus 2. And if I were to subtract 6x on both sides, my variable actually completely disappears, but I have a true statement, okay? So it's different from your equations where it's like 5 equals 5 or x equals x, like that type of problem solution that you have, where basically what you see here is that the variable goes away, but the number sentence that you see is true. And this is what we call an all real solution. So yeah, all real solution answer. Because you could replace x with any number and your number sentence should be true, okay? And in the end, it's really because your terms with your variables just cancel out anyway, and then you're going to be left with 8 is greater than 2. And this, in the end, is a true statement. So this is true, and that therefore you have an all real solution. This one, the statement that you ended up with in your answer is false. Therefore, this is what we call a no solution. Okay. All right, that's all I have for you today. This just takes practice working with equations. It's really the same type of concept. We just have to think one step further with our inequality. All right, that's all I have for today.